This is the EdExcel GCSE 91 Maths Paper 2 from the higher tier, and it's from the June 2017 series. Question number 1. The table shows the probabilities that a biased dice will land on 2, on 3, on 4, on 5, and on 6. And we see the associated probabilities for landing on a 2, 3, 4, 5, and on a 6. Neymar rolls the biased dice 200 times. We have to work out an estimate for the total number of times the dice will land on 1 or on 3. Well, first of all, we need to find this missing probability here. Now, we know already that probability adds up to 1, and if we let x be the probability of landing on a 1, then we have x plus the 0.17 plus the 0.18 plus the 0.09 plus 0.15 plus 0.1. All of this adds together to give 1. So if we tidy this up, you can see we've got x plus 0.69 equals 1. And if I subtract 0.69 from both sides, you can see x is equal to 0.31. So the probability that we land on a 1 is equal to 0.31. Now, let's now find the probability that we land on a 1 or land on a 3. So, the probability that we land on a 1, that's equal to 0.31. And the probability that we land on a 3, that's 0.18. So if I work this out, it turns out we get 0.49. Now, if we roll the dice 200 times, the estimate for the total number of times we land on a 1 or a 3 will be 200, because we're rolling the dice 200 times, multiplied by this 0.49. So it turns out here we get 98. So we will land approximately 98 times on a 1 or a 3. Question number 2. On Saturday, some adults and some children were in a theatre. The ratio of the number of adults to the number of children was 5:2. Each person had a seat in the circle or had a seat in the stalls. 3/4 of the children had seats in the stalls. 117 children had seats in the circle. There are exactly 2,600 seats in the theatre. On this Saturday, were there people on more than 60% of the seats? You must show how you get your answer. So first of all, you can see that there's two types of seats: circle or stalls. And you can see 3/4 of the children had seats in stalls, and 117 children had seats in the circle. So if 3/4 of the children had seats in the stalls, that means that 1/4 of children had seats in circles. And 1/4 would represent 117 children. So therefore, that tells us from here, if I multiply through by 4, you will find that we have 468 children. So we've got 468 children in total. And if we take a look at the ratio of adults to children, so the ratio of adults to children, you can see here we've got 5 to 2, and that was told to us in the question. Now we know already we've got 468. We were told this, rather we worked this out over here. So with this we can find out how many adults we have. Well, to go from 2 to 468, we need to multiply by 234. So we will multiply 5 by 234, and if I work out 5 times by 234, it turns out we get 1170. So the total amount of people, this will equal 1170 plus 468, which is 1638. And therefore, the percentage of seats that are taken, well, we've got 1638 over 2000. And then obviously we need to multiply by 100. So if we work this out, we have 1638 over 2000, and then multiply this by 100. It turns out we get, so 13, rather here we've got 2600. So it turns out we get 63%. So 63% of seats are taken, which is greater than the 60% which was suggested, and therefore we can conclude, yes, that indeed more than 60% of seats were taken. Question number 3. The diagram shows a prism with a cross-section in the shape of a trapezium. So that's what we see here. And on the centimeter grid below, we have to draw the front elevation and side elevation of the prism. We have to use a scale of 2 centimeters, would represent 1 meter. So if we first of all take a look at the side, we've got this 1 meter over here. So let's just highlight this. Here we've got a 1 meter length, which will be 2 centimeters on this grid. So that will be this side over here. Actually, because it's the bottom one, let's just draw it here. And then because we've got 0.5 meters going up like this, I'll just do this one. Because we've got 0.5 meters going up like this one here will be 1 centimeter. So we've got 1 centimeter over here. And if I finish off the box, you can see here we have the side elevation. And if we take a look at the front elevation, well, here we've got the 2 meters, and if we use the scale, if 1 meter is represented by 2 centimeters, 2 meters will be represented by 4 centimeters. So we've got 4 centimeters going down here. We then have 2 meters going this way as well, so that again will be 4 centimeters going across here. And the height is 0.5 meters, which we discussed before. That's just 1 centimeter going up, and then we join the line up here to complete the front elevation. So here we've got the front elevation. Question number 4. Ollie drove 56 kilometres from Liverpool to Manchester. He then drove 61 kilometres from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometres per hour. Ollie took 75 minutes to drive from Manchester to Sheffield. For part A, we have to work out Ollie's average speed for his total drive from Liverpool to Sheffield. Well, I think the best way to do this question is through a diagram to help illustrate what we know already. So here you can see we've got Liverpool, Manchester and Sheffield. Now, the distance between Liverpool and Manchester, that's 56 kilometres. So here we've got 56 kilometres. And then from Manchester to Sheffield, we've got 61 kilometres. And the average speed from Liverpool to Manchester was 70 kilometres per hour. And Ollie took 75 minutes to drive from Manchester to Sheffield. So here, Manchester to Sheffield, we have 75 minutes. And what we need to do is find out the average speed from Liverpool to Sheffield. So, first of all, the formula that connects speed, distance and time can be seen in this triangle. So, what else we need to know? To go from minutes to hours, we divide by 60, hours to minutes, we times by 60. So we can convert the 75 minutes into hours by 60. So, if we divide 75 by 60, you'd find we get 1.25. So 75 minutes is equivalent to 1.25 hours. And the reason I want to do that is because I want all the units to be consistent. Now, we can use this formula over here to work out the time it takes to travel from Liverpool to Manchester. So, we know that time is equal to distance divided by speed. So the speed, rather the time, from Liverpool to Manchester, this will be the distance, 56, divided by the speed, which is 70. So it turns out here we get 0.8. So here we travelled to Liverpool to Manchester in 0.8 hours. Okay, so from this we can see that the total distance from Liverpool to Sheffield, we have 56 plus 61, which is 117 kilometers, and the total time, this is equal to 0.8 plus 1.25, so it turns out here the total time is 2.05 hours. And again, we can use this formula here to work out the average speed. So therefore, the average speed is equal to the total distance, 117 kilometers, over the total time, which is 2.05 hours. So if we work this out, we get 117 divided by 2.05, which is 57.1 kilometers per hour, and this is given to 3 significant figures. So we have 51.7, rather here we've got 57.1 kilometers per hour given to 3 significant figures. Now for part B, Janie drove from Barnsley to York. Janie's average speed from Barnsley to York, from Barnsley to Leeds was 80 kilometers per hour. Her average speed from Leeds to York was 60 kilometers per hour. Janie says that the average speed from Barnsley to York can be found by working out the mean of 80 kilometers per hour and 60 kilometers per hour. Is Janie correct? And what does this tell you about the two parts of Janie's journey? Well, if we think about the formula given over here, what we can see is if we're taking the average speed to be the mean of 80 kilometers per hour and 60 kilometers per hour, that suggests that the time taken for the two parts of the journey must be the same for us to find the mean. So the time taken for the two parts of the journey must be the same. Question number 5. ABC and EDC are straight lines. EA is parallel to DB, EC is 8.1 centimeters, DC is 5.4 centimeters, and DB is 2.6 centimeters. We have to work out a length of AE. Now to do this, first of all you need to recognize that ABC and EDC are similar triangles. So what we can first of all do is draw out those triangles to help visualize what exactly we need to work out given what we've been given. So we've got two triangles over here, and we've got EC, which is 8.1. We've got DC, which is 5.4. And we've got DB, which is 2.6. We have to work out what AE is. Now, because EC and DC are similar to each other, we can first of all work out a length scale factor. The length scale factor is equal to 8.1 divided by 5.4. So if we work this out, it turns out we get 1.5. So to go from the big shape to the small shape, we'd have to divide by 1.5. Small shape to big shape, we have to times by 1.5. And from this we can work out what AE is. AE, that will equal 2.6 multiplied by the 1.5, which is 3.9. So we've got 3.9 centimeters for AE. We've got 3.9 centimeters here. And now for part B, AC is equal to 6.15, so here we've got 6.15, and we have to work out the length of AB. So we have to work out this length here. Now what we can do is actually work out what BC is. We can work out BC by dividing 6.15 by 1.5. So BC, that's equal to 6.15 divided by 1.5. So if I work this out, 6.15 divided by 1.5, that's 4.1. So we've got 4.1 over here. So this total length is 6.15. This length is 4.1. So therefore, AB is equal to 6.15 take away 4.1, which is 2.05. So we've got AB, which is 2.05 centimeters. Question number 6. Anil wants to invest £25,000 for 3 years in a bank. There's two types of bank. Personal bank, compound interest is at 2% for each year. Secure bank, compound interest is 4.3% for the first year and 0.9% for each extra year. Which bank will give Anil the most interest at the end of the 3 years? So one way which we can approach this, well, if we take a look at personal bank, the interest, we'll call the interest I, is equal to, well, if we got 2% per year, that means the interest is 1.02 to the power of 3 because we're investing for 3 years. So if I work out the value of 1.02 to the power of 3, it turns out we get 1.061208. And if we now take a look at secure bank, for secure bank we've got the interest, which is equal to 4.3% for the first year, so here we've got 1.043, and then we've got 0.09% for each extra year. So if we're investing for 3 years in total, we're going to have 2 extra years. So here we've got 1.009 squared. So if we work this out, 1.043 times by 1.009 squared, it turns out here we get 1.06185, etc. So therefore, what you can hopefully see is that the secure bank gives the most interest. Question number 7. A number n is rounded to 2 decimal places. The result is 4.76. Using inequalities, we have to write down the error interval for n. For the error interval, we've got the lower bound, which is less than or equal to n, which is less than the upper bound. So, for the lower bound, this is equal to 4.755, and for the upper bound, this is equal to 4.765. So when we come to write down the error interval for n, we have 4.755, which is less than or equal to n, which is less than 4.765. Question number 8. The cumulative frequency graph shows some information about the heights in centimeters of 60 students. We have to work out an estimate for the number of these students with a height greater than 160 centimeters. Well, 160 centimeters is here, so we need to draw a vertical line up from 160 centimeters first. So here is our ruler, and what we need to do first of all is draw a vertical line up from 160 centimeters. So let's do that. And then we see where this vertical line intersects the curve, and then draw a horizontal line. So if we have a horizontal line, here is our horizontal line. And you can see, hopefully, at this point, we have 48. So when we come to think about an estimate for the number of students with a height greater than 160 centimeters, we have the value shown by the difference between 60 and 48. So if we work this out, it turns out we get 12. So therefore, we have 12 students as our estimate. Question number 9. The diagram shows a triangle A drawn on a grid. That's what we see here. Kyle reflects triangle A in the x-axis to get triangle B. He then reflects triangle B in the line y equals x to get triangle C. Amy reflects triangle A in the line y equals x to get triangle D. She's then going to reflect triangle D in the x-axis to get triangle E. Amy says that triangle E should be in the same position as triangle C. Is Amy correct? You must show how you get your answer. So, first of all, you'd notice that both Kyle and Amy are reflecting the shapes in the line y equals x. So I think it might make sense for us to draw the line y equals x. Here we've got the line y equals x. Now let's take a look at what Kyle did. Kyle reflected shape A in the x-axis to get triangle B. So let's just take a look at this statement alone. If I reflect shape A in the x-axis, here is the x-axis, we get shape B. So shape B will be over here. So here we have shape B. Then shape B is reflected in the line y equals x to get the triangle C. So we then reflect shape B in the line y equals x to get shape C. So if we draw shape C, we would have something over here. You can see we have now reflected shape B in the line y equals x to give shape C. Let's now take a look at what Amy said. Amy reflects shape A in the line y equals x to get shape D. So if we reflect shape A in the line y equals x, here, rather, if we reflect here, we get shape D. Then shape D is reflected in the x-axis to give shape E. So let's take a look at this line. If I reflect D in the line y equals 0 or the x-axis, we would get something looking like this. So here we have E. And if we take a look at what Amy is saying that E is in the same position as C, and you can clearly see they are not in the same position. So therefore, she is incorrect because C and E are in different quadrants. Question 10. The table shows some information about 8 planets. So we see the planets over here. We've got the distance from Earth in kilometers, and we've also got the mass in kilograms. For part A, we have to write down the name of the planet with the greatest mass. Well, first of all, you'll find that all the masses are given in standard form. So when we come to find the planet with the greatest mass, we're looking for the greatest power of 10. And you can see Jupiter has the greatest power of 10. Here we've got 10 to the 27, which is bigger than every other power. So for part A, we simply write down Jupiter. Now for part B, we have to find the difference between the mass of Venus and the mass of Mercury. So the mass of Venus, that is 4.869 times by 10 to the 24, and the mass of Mercury, you can see that's 3.302 times by 10 to the power of 23. So if I work this out, we have 4.869 times 10 to the 24 minus 3.302 times 10 to the 23. You can see here in standard form, we get 4.5388 times by 10 to the 24. So therefore, the difference in masses, that will be 4.5388 times by 10 to the 24 kilograms. And for part C, Nishat says that Neptune is over 100 times further away from Earth than Venus is. Is Nishat right? You must show how you get your answer. Well, what we'll do over here is see how many times further the planet Neptune is from Earth. So if we take a look at Neptune, here we've got 4.35 times 10 to the 9. And if we take a look at what we have for Venus, that's 4.14 times 10 to the 7. So here, what we have is 4.35 times by 10 to the power of 9 divided by 4.14 times 10 to the power of 7. So if we work out what this is, we have 4.35 times by 10 to the power of 9 divided by 4.14 times by 10 to the 7. You find here we get 105.07, etc. And of course, this is over 100. Of course, the 100 times is what we're looking at here. So therefore, we can conclude that this person is correct. Question 11, we have to solve 3x minus 2 over 4 minus 2x plus 5 over 3 equals 1 minus x over 6. Now to do this, it might make sense for us to get rid of every single fraction here. And we can do that by multiplying through by the lowest common multiple of 4, 3 and 6. Of course, the lowest common multiple is 12, so we will multiply each term by 12. So if we do that, 12, the 4 cancels with the 12 3 times. The 3 cancels with the 12 4 times. And the 6 cancels with the 12 twice. So we have 3 lots of 3x minus 2 minus 4 lots of 2x plus 5 equals 2 lots of 1 minus x. We now need to solve this linear equation. We can do this by multiplying the 3 into this bracket, the minus 4 into this bracket, and the 2 into this bracket. So we've got 3 times by 3x, of course that's just 9x, 3 times by minus 2, that's minus 6, minus 4 times by 2x, that's minus 8x, minus 4 times by 5, that's minus 20, 2 times by 1, that's 2, 2 times by minus x, that's minus 2x. So if we tidy up the left hand side, 9x minus 8x, that's just x, and minus 6 minus 20, that's minus 26. And on the right hand side, we've got 2 minus 2x. So with this equation, if we gather everything involving an x on one side, and everything that's not an x on the other side, well, x plus 2x, that's going to be 3x, and 2 plus 26, that's 28. So we have 3x equals 28. Of course, x is just equal to 28 over 3. And this answer is in exact form. So x is equal to 28 over 3. Question number 12. There are 30 students in Mr. Lear's class. 16 of the students are boys. 2 students from the class are chosen at random. Mr. Lear draws this probability tree diagram for this information. So here we've got the first student being picked and then the second student. And for part A, we have to write down one thing that is wrong with the probabilities in the probability tree diagram. Well, here we need to assume that he doesn't replace. So in other words, once he's picked a student, that's it, the student's picked. So for the second student, the probability should be out of 29. So for the second student, the denominator should be 29, not 30. And now for part B of the question, Owen and Wasim play for the school football team. The probability that Owen will score a goal in the next match is 0.4. The probability that Wasim will score a goal in the next match is 0.25. Mr. Slater says the probability that both boys will score a goal in the next match is 0.4 plus 0.25. Part B then, is Mr. Slater right? Give a reason for your answer. Well, of course, here he needs to multiply the probability. So, of course, when we multiply the probabilities, we can find the probability that they both score goals, and if we find that out, we get 0.1125, and therefore we can conclude that Mr. Slater is incorrect. Question 13. The histogram shows some information about the ages of the 134 members of a sports club. So you can see here we've got the age in years and we've got the frequency density. 20% of the members of the sports club who were over the age of 50 are female. We have to work out an estimate for the number of female members who are over 50 years of age. Well, what we can first of all do here is work out the frequencies. So we know already that frequency is equal to frequency density multiplied by class width. So for each of these bars, let's work out the frequency. Here we've got 10 times by 1.1, which is 11. We have 11 over here. Here we've got 10 multiplied by 2.8, which is 28. Here we've got 20 multiplied by 2.3, which is 46. Here we've got 20 multiplied by 1.4, which is 28. And here we've got 30 multiplied by 0.7, which is 21. What we also know is that 20% of the members of the sports club who are over the age of 50 are female. So the age of 50, that is over here. So let's just draw a vertical line down from here. Here we've got 50, and everything beyond this point is the people who are over the age of 50. So here what you see shaded is everyone who's over the age of 50 years, and here of course we've got 50 females. Rather here we've got females who are over the age of 50. So what we need to do is find out what the total is over here in red. Well, we've got here 10 multiplied by 1.4 plus the 21 over here. So here we get 35. So what we need to do here is work out 20% of this 35. So we've got 35 people are shown here, and 20% of those are female. So in other words, we've got 20% of 35, which is 7. So we have 7 members who are female over the age of. Question number 14. Here are some graphs, and in this table over here we have to match each equation with the letter of its graph. So y equals sin x, well, of course that will be graph C. Starts at 0, here it crosses at 180. We've got a maximum at 1, a minimum at -1. So here we have graph C, y equals x cubed plus 4x. Well, we've got a cubic, and the only graph which is a cubic is graph F. Y equals 2 to the power of x, of course this is just a exponential graph, that corresponds to graph A. So we have graph A over here, and y equals 4 over x, that's a reciprocal graph, that will be of course graph H. Question 15. A, B, C and D are 4 points on the circumference of a circle. A, E, C and B, E, D are straight lines. We have to prove that the triangle A, B, E and the triangle D, C, E are similar. You must give reasons for each stage of your working. Well, first of all, C, E, D and A, B, E are vertically opposite angles, and of course those will be equal. So this angle over here is equal to this angle over here. Let's write that down with the reason. So CED and ABE are equal because we have opposite angles around a point. Now we have BAE and CDE, which are also equal. So this angle is equal to this angle. Of course, the reason for that is angles in the same segment are equal. So BAE and CDE are equal because angles in the same segment are equal. And similar to that, we've got ABD, which is this angle here, and ACD, which is this angle here, are also equal for the same reason as above. So of course ABD and ACD are equal because angles in the same segment are equal. So therefore, what we can conclude is 3 pairs of angles. We've got 3 pairs of equal angles, and therefore the triangle. Question number 16. Using algebra, we have to prove that 0.136 recurring, where the 3 and the 6 are repeating, multiplied by 0.2 recurring, where the 2 is just repeating, is equal to the value 1 over 33. Well, we will begin by letting x say equal. So we're going to let x equal 0.136, 3, 6, 3, 6, etc. So we've written out the 0.136 recurring, and we've associated that with a letter x here. And because two digits are repeating, we can multiply x by 100. So we have 100x equals, well, if I multiply this value by 100, we get 13.63636, etc. So now we will subtract these. So we have 99x equals, well, if I subtract these, you can see hopefully these values cancel out. We are left with 13.6 take away 0.1, which is 13.5. And therefore, if we find out what x is equal to 13.5 divided by 99. So if we use our calculator, 13.5 divided by 99, that turns out to be, rather here we've got 99, it turns out here we get 3/22. So of course x is equal to 3/22. And we will do a similar thing with this 0.2 recurring. Here we will let y equal 0.2222, etc. And because we've got one digit repeating, we can multiply this by 10. So we have 10y equals 2.2222, etc. And in a similar way, the terms here cancel out. 10y take away y, that's 9y. So we have 9y equals, well, here we've got 2 take away 0, which is just 2. Of course, we can conclude y is equal to 2/9. And if we pay attention to what we want to show, we want to show that 0.136 recurring, where the 3 and the 6 are repeating, multiplied by 0.2, where the 2 here is recurring. We've got 3/22 multiplied by 2/9, and you'd find here we get 1/33, and that's exactly what we wanted. Question number 17. ONQ is a sector of a circle with center O and radius 11 centimeters. A is the point on ON and B is the point on OQ, such that AOB is an equilateral triangle of side 7 centimeters. So first of all, let's just add in this information. We have an equilateral triangle and each side is 7 centimeters. We have 7 centimeters here, 7 centimeters here, and 7 centimeters here. And because we have an equilateral triangle, each angle is 60 degrees. We have 60 degrees here, 60 degrees here, 60 degrees here. Now, if the radius is 11 centimeters, that means that this entire length is 11 centimeters. So this length here is 11 take away 7, which is 4. So we have 4 centimeters here, 4 centimeters here. 4 plus 7 gives the 11. we have to calculate the area of the shaded region as a percentage of the area of the sector or NQ. Give your answer correct to 1 decimal place. Well, first of all, we can find out the area of the sector, and if we find out the area of the triangle and subtract it from the sector, that tells us the shaded area, and from that we can find the required percentage. So for the sector, or NQ, we have here theta over 360 multiplied by pi r squared. So we have theta, which is 60 degrees. So we've got 60 over 360 multiplied by pi multiplied by the radius squared. Of course, the radius is 11, so we multiply by 11 squared. Let's work this out. So we have 60 divided by 360 times pi times 11 squared, which is 121 pi over 6. So we have 121 pi over 6 centimeters squared. Let's now find out the area of triangle A or B. We have here 1/2 AB sine C. So we have 1/2 times by 7 times by 7 times by sine 60. So if we work this out, 49 over 2 multiplied by sine 60 gives us 49 root 3 over 4. So we have 49 root 3 over 4 centimeters squared. So therefore, for the shaded area, we've got over here 121 pi over 6 minus 49 root 3 over 4. So let's work this out. We have 121 pi over 6 minus this. It turns out we get 42.13 etc. centimeters squared. So therefore, the percentage this is equal to, well, we've got the 42.13 etc. So this is the shaded region, and we divide this by the original sector, which is 121 pi over 6. So we will divide this by 121 pi over 6, and of course we then multiply by 100. So we've got this value divided by 121 pi over 6, and then we multiply by 100. It turns out we get 66.5%. So we've got 66.5% to 1 decimal place. So here we have 66.5% to 1 decimal place. Question 18. We have 6 to the power of 1/5 times 2 to the power of x equals 8 to the power of 3/4, and we have to work out the exact value of x. So to do this question, we need to make the bases the same. So if we think about 16 to the power of 1/5. Well, 16 we can rewrite that as 2 to the power of 4. So 16 is the same as 2 to the power of 4. And then we will raise this value to the power of 1/5. We then multiply by 2 to the power of x. And this is equal to 8 to the power of 3/4. But we know 8 is 2 cubed. So we've got 2 cubed to the power of 3/4. Of course here, 8 is the same as 2 cubed. Now you can see the bases are the same. So now we need to use the laws of indices. First of all, here we have the law of indices. A to the power of m to the power of n is equal to a to the power of mn. We multiplied the powers when we have a base to a power to another power. So 2 to the power of 4 to the power of 1/5, that will be 2 to the power of 4 times by 1/5, which is 4/5. We then multiply this by 2 to the power of x, and this is equal to, well, here we've got 2 to the power of 3 to the power of 3/4, again using the rule here. This is the same as 2 to the power of 9/4. Now, you can see on the left hand side, we have the same base. We are multiplying. Of course, we need to use the law of indices. A to the power of m times by a to the power of n is equal to a to the power of m plus n. So we need to add the powers when we have the same base and we're multiplying. So here on the left hand side, we need to add the powers. We of course have 2 to the power of 4/5 plus x equals 2 to the power of 9/4. And if we now compare the powers, we've got 4/5 plus x equals 9/4. And if we subtract 4/5 from both sides, we have 9/4, take away 4/5, which is 29/20. So therefore, x is equal to 29/20. So x is 29/20. Question number 19. We have 2 minus x plus 2 over x minus 3 minus x minus 6 over x plus 3, which can be written as a single fraction in the form ax plus b over x squared minus 9, where a and b are integers. We have to work out the value of a and work out the value of b. Well, to do this question, we need to put everything over a common denominator. That might be a good starting point. And I think the common denominator here will be x minus 3 lots of x plus 3. So, let's just draw a line like so. We have x minus 3 lots of x plus 3 being our common denominator. So for each term, let's just write the common denominator, x minus 3 and x plus 3. Okay? So, what we now need to do, well, over here, 2 is the same as 2 lots of x minus 3 lots of x plus 3. It's as though the x plus 3 and the x minus 3 cancel on the top and bottom. And then we subtract off. Well, here, we still need the x plus 2 on the top. On the bottom, we still want the x minus 3, so we want the x plus 3's to cancel on the top and bottom, leaving us with x plus 2 over x minus 3. and that's what we see here. And then we subtract off. Well, here we want an x minus 6 on the top. We want an x plus 3 on the bottom. Well, I need to get rid of this x minus 3 on the bottom, so the way I can do that is having an x minus 3 on the top as well. It's as though these cancel out. And now that we have a common denominator, we can combine these fractions into a single fraction. So let's do that. We have 2 lots of x minus 3 lots of x plus 3 minus x plus 2 lots of x plus 3 minus x minus 6 lots of x minus 3. And on the bottom we've got this common denominator of x minus 3 x plus 3. So this is our combined fraction, and now we need to tidy all of this up. Well, over here on the top we've got 2 lots of, well, x minus 3 lots of x plus 3, that's x squared minus 9, and then we subtract off over here. Well, we've got x times by x, that's x squared, and then x times by 3, and then 2 times by x, that'll just give 5x. 2 times by 3, that will give 6. And then we subtract off. Well, here we've got x times by x, that's x squared, x times by minus 3, and then minus 6 times by x, well, that will be minus 9x. And then minus 6 times minus 3, that's positive 18. And on the bottom, we still have the x minus 3 lots of x plus 3. So, let's tidy this up even further. Well, we've got 2 times by x squared, that's 2x squared, 2 times by minus 9, that's minus 18, and then here I've got minus x squared, and then I've got minus 5x, and then minus 6, and then I've got minus x squared, and then here I've got plus 9x, and then I've got minus 18. And on the bottom, we've got x minus 3 lots of x plus 3. So we can tidy up the top. Let's see what cancels out. Well, we've got 2x squared minus x squared minus another x squared, that will give 0x squared. And then we've got minus 5x plus 9x, that's 4x. So let's just sort out the bottom first. On the bottom we've got x minus 3 lots of x plus 3, and on the top we've got 4x. And then minus 18 minus 6 minus another 18, that's minus 42. So, on the bottom, if we expand the bottom, what we end up with is x minus 3, and then x plus 3 on the bottom, and on the top we've got 4x minus 42. So hopefully you can see a is equal to 4 and b is equal to minus 42. And of course, rather, I should have expanded on the bottom. On the bottom we get x squared minus 9. So this is what we get on the bottom. So this is our final answer. Question 20. The diagram shows part of the graph of y equals x squared minus 2x plus 3. So that's what we see here. And by drawing a suitable straight line, use the graph to find estimates for the solutions of x squared minus 3x minus 1 equals 0. So if we compare the x squared minus 2x plus 3 with what we have over here? Well, if I set this, rather, if I take a look at this graph, that's what's been drawn here. What I need to go to is this graph over here. So I need to go to the graph of x squared minus 3x minus 1. And for me to go from this graph to this graph, well, to go from the minus 2x to the minus 3x, we subtracted 1. So here, we subtracted 1, x, and then to go from the 3 to the minus 1, I need to subtract off 4. So, this graph over here has already been drawn, and somehow we need to find out the solutions to this graph over here. So if I, of course, set this graph equal to x plus 4, we can rearrange that to get this graph over here. So, if we have x squared minus 2x plus 3 equals x plus 4, then if I subtract x and subtract 4, we end up with this graph over here. So I need to draw the graph of x plus 4. So we need to draw the graph of x plus 4. We need to draw this graph over here. So of course we've got a gradient of 1. It passes through the point 4 over here. So it looks something like this. So here, what's drawn here is the graph of y equals x plus 4, and where this graph intersects this curve here are where the solutions are. So if we find the intersection points, well, we've got one over here, and we've got another one over here. So for this solution, well, we've got we've got 10 little squares here, and we want every little square is 0.2, so here we've got minus 0.2 minus 0.3. So we've got x equals minus 0.3, and we've got another solution here. Well, here we've got 3.2, then 3.3. So we've got 3.3 for our other solution. And now for part B, P is the point on the graph of y equals x squared minus 2x plus 3, where x equals 2. And we have to calculate an estimate for the gradient of the graph at the point P. So what we need to do over here is, well, if we take a look at where x equals 2, that's over here. And what we need to do is find the gradient at this point. So if we find out the gradient, well, first of all, let's just draw on for ourselves a quick gradient. So here, let's just draw on a quick gradient. So we need to find the gradient of this orange line over here. Okay, so if we find out the gradient of, well, let's just draw it again more neatly. And if I draw it, okay, we have something looking like this. So I need to find out the gradient of this line over here. Okay. So if we consider a change in x, we've got a change of x over here of, well, we're going from here, we're going from 1 to 3, so the change in x is 2. And if we consider the change in y, we're going from over here 1 to, well, here we've got 5, so here we've got 4.8. So we've got 4.8 take away 1, which is 3.8. So the change in y is equal to 3.8. So just make sure we've done that right. So change in y, that's here we've got 4.8 take away 1, and the change in x is 3 take away 1, which is 2. So therefore, for the gradient, we've got change in y over change in x. So we've got 3.8 over 2, which is equal to, well, 3.8 divided by 2, which is 1.9. So we've got 1.9 as an estimate for our gradient. Question 21. The diagram shows 3 identical circles inside a rectangle. Each circle touches the other 2 circles, and the sides of the rectangle are shown in the diagram, so that's what we see here. The radius of each circle is 24 millimeters, and we have to work out the area of the rectangle. Well, to work out the area of the rectangle, I need the length over here and the height over here. So, what we know already, the radius of each circle is 24 millimeters. So, from this, we can actually find out what the length is of the rectangle. And this is actually quite straightforward. If here we've got 24, then here we've got, if I just mark all these on, we've got 24 over here, and then we've got another 24 here, so we've got 48 plus another 48, which is 96. So we have 24s going across over here. So let's just show a rectangle. Here is our rectangle, and if I add the dimensions, you can see here we've got this length over here, which is 96. And if we find out the height, well, for us to find out the height, let's see what we can first of all deduce from this diagram. Well, from here to here, okay, let's just show this in red. We have from here to here length of 24, and here to here we'd also have a length of 24. But then we've also got this bit over here, which is currently unknown. So let's just actually show that more clearly. Let's just make our ruler go vertical. So if I add this on, we've got here the 24. Here we've also got 24, but then we've also got this bit over here as well, which we need to work out. So we've got here 24. Here we've also got 24. We don't know this height over here. But if we think about it, we can actually work that out. Of course, from here to here, because the radius goes from the center to the circumference, here and also here, we have 24 plus 24. So here to here is 24 plus 24, which is 48. So we've got 48 over here, and we've also got 48 over here. But this green line over here is perpendicular to this blue line, so we've got a right angle triangle. And if we work out what the height is of the green triangle, well, let's just draw that out over here. Actually, let's just draw it out again. We've got here this blue length, which is 48. Well, half of that actually will be 24. So we've got 24 here. So let's just draw that again. Here we've got 24 here and 24 here. And then we've got this height over here. And then we've also got, if I work this out, we've got 48, so that is, right, show that here, we've got here this line, which is 48, and we've also got this one here, which is also 48. So to work out the green one, of course, here we just simply need to use Pythagoras. So let's just show that. Okay. So here we need to use Pythagoras. We'll call this x. So to work out what x is, we've got 40. Well, we've got x squared equals 48 squared minus 24 squared. So if I work that out, 48 squared minus 24 squared, that's 1728. So here we've got x squared equals 1728, and if I square root this, we get 24 root 3. So therefore x is equal to 24 root 3. Well, how does this help us? If I go back to the diagram, we can add this length in as 24 root 3. So now the total height over here will be 24 root 3 plus 48. So here I get 48 plus 24 root 3. So let's add this in. We've got 48 plus 24 root 3. So to work out the total area, we can therefore conclude that the area is equal to 24 root 3 plus 48 times by 96. So if I multiply this by 96, we get over here we get 8598.64 etc. millimeters squared, and therefore to three significant figures we have 8600 millimeters squared. Question 22. Here are the first 5 terms of a sequence. We've got 4, 11, 22, 37 and 56. We have to find an expression in terms of n for the nth term of the sequence. Well, let's find the difference between each term. The difference between these two terms is positive 7. Difference between these two terms is positive 11. difference between these two terms is positive 15. The difference between these two terms is positive 19. Now, if we find the difference between each of these, we've got 4 here, 4 here, and 4 here. Now, of course, because this difference is constant, we can divide 4 by 2 to find out the coefficient of n squared for this quadratic sequence. So 4 divided by 2, that's of course equal to 2. So we have a 2n squared. Now, let's find the square numbers, n squared of course. We've got here 1, 4, 9, 16, and 25. The two n squared terms, 2 times by 1 is 2, 2 times 4 is 8, 2 times 9 is 18, 2 times 16 is 32, 2 times 25, that's 50. Let's now write out our sequence as we see over here. We've got our sequence 4, 11, 22, 37, and 56. So now if we work out the difference between the sequence and the two n squared terms, 4 take away 2, that's 2, 11 take away 8, that's 3, 22 take away 18, that's 4, 37 take away 32, that's 5, 56 take away 50, that's 6. If we find the difference between each of these terms, you'd find we get a positive 1. So to find the, well, because we've got a positive 1, we can conclude here we've got a 1n. And if we find the 0th term, we can do that by subtracting 1. And if we subtract 1, you will find 2 take away 1 is just 1. So therefore, we've got 2n squared plus n plus 1. So this is our expression for the nth term of the sequence. Question 23. L is the circle with equation x squared plus y squared equals 4. P with coordinates 3, 2 and root 7 over 2 is a point on L. We have to find an equation of the tangent to L at the point P. Now, I think it might be a good idea to first of all sketch the graph of x squared plus y squared equals 4. So here, sketched on an axis, we've got x squared plus y squared equals 4, and the 4 I've rewritten as 2 squared. The reason I've done that is because I can identify the length of the radius is 2. So the graph intersects here at the point 2, at the point here, at the point here, 2, at the point here, minus 2, and at the point here, or at the point here, minus 2, and the point here, minus 2 as well. Now, I've got the point 3 over 2 and root 7 over 2, and that's a point on L. And if I show that somewhere here, we've got the point P with coordinates 3 over 2 and root 7 over 2. And now if I draw a tangent to this circle, so if I draw a tangent, we need to work out the equation of the tangent, and I'll show it in green. So here is our tangent. So this is the tangent to L at the point P. Okay? And what we need to do, of course, here is find out this point. But what we also need to identify is that here we've got a radius which is perpendicular to the tangent. So because it's perpendicular, here we've got 90 degrees. So if we find out the gradient of the radius, we can use that to find out the gradient of the tangent, and then from that, because we know the point P over here, we can find the equation of the tangent. So for the gradient of the tangent, well, over here rather, we need the gradient of the radius rather. So here I've got the change in y, which is √7 over 2, and the change in x, which is 3 over 2. And of course, working this out, it turns out we get √7 over 3. So this is the gradient of the radius, and therefore for the gradient of the tangent, this is the negative reciprocal of √7 over 3, which is minus 3 over √7. So this is the gradient of the tangent. And now, if we consider the point P with coordinates 3 over 2 and √7 over 2, we need to find out the equation of the tangent. So we can use, of course, y equals mx plus c. So we've got y, which is √7 over 2, equals m, which is minus 3 over √7, lots of x, which is 3 over 2, plus c. And we need to find out what c is. So c is equal to, well, here we've got √7 over 2 minus, well, here we're going to have plus actually, because if I take this over to the other side, it becomes a plus. So I'm going to add on 3 over √7 multiplied by 3 over 2. You will find c to equal, if I've done it correctly, 8√7 over 7. So therefore, for the equation, I've got y equals m, which is minus 3 over √7. So here we've got 3 over √7, which is 3 √7 over 7. So I've got minus 3 √7 over 7 x plus 8 √7 over 7 for my y-intercept. So this is the equation of the tangent. Okay, so here we've got the equation of the tangent over here.